And remember what I said, the ultimate goal of this section, not including the sine law and cosine law lessons, but the ones we've been working on since the last test, have been working towards how can I find values of certain trig, or the, how do I say this? Like if I say take the sine of a certain angle, how can I find it without using a calculator? If I take the cosine of a certain angle, how can I find it without using a calculator? Tangent, same idea. Okay. And then not only finding those values, okay, when we take the sine, cosine, or tan of certain angles, we're not going to do every angle because that's crazy. Can you imagine you'd have to measure you'd have to remember every angle from 1 to 360 degrees? So that would be how many answers would you have to remember if we did that? 180, 360, 540 values. You guys could do that, couldn't you? Okay. I see deer in headlights. Anyway, we're just going to focus on certain angles. Okay. Common angles that we use and that we see. Okay. And those common angles are going to start with 30 degrees, 60 degrees, and 90 degrees. Like if you look around this room, you can probably see angles that are 45 degrees. You can probably see ones that are 30 and 60. Like those triangles up there, up above this set of lights here, or this set of lights here, those are equilateral triangles. They all have 60-degree angles. And then there's two other sort of upside down right triangles that are with them. They have 30-degree angles with them, or 90-degree angles with them. Okay. So, I mean, angles that are commonly used, especially in things like construction, architecture, design, things like that. Okay. All right. One last thing before we start learning how to, actually two more things before we actually start learning how to do the trig stuff. Okay. Is certain right triangles that have certain common acute angle measures. So remember I said 30 degrees, 45 degrees, and 60 degrees were common. Well, here is a right triangle. If you make a right triangle with one of the angles 45 degrees, why does the other one have to be 45 degrees too? They need to add up to 180, right? If this is 45 degrees and it's a right angle, one of the others must be 90. 90 and 45 is 135, which means the other angle must be 45. So whenever you make a right triangle with one of the angles 45, the other angles are going to be 45 automatically. Okay, so here we have, and then we're going to use some easy numbers for the lengths, 1 and 1, because those are easy to work with. How would I find the length of the hypotenuse here? Yeah. We would say to find the hypotenuse, we would go 1 squared plus 1 squared equals the hypotenuse squared. A squared plus b squared equals c squared. What's 1 squared and 1 squared? Really? 1 squared plus 1 squared? Thank you. I didn't hear anybody. That's why I'm sitting here waiting. You guys, like, what's 1 squared plus 1 squared? That's what you guys sound like to me. And then you look at me like I'm the idiot. Therefore, the hypotenuse is going to be what? The square root of 2. But remember, remember how we work with radicals now? If we can't take them exactly, we leave them. Unless we can simplify them by finding the highest perfect square, but there's no highest perfect square. So, if we have and I'm going to call it a 45, 45, 90 right triangle, where the legs are 1, the hypotenuse must be 1 over root, or must be root 2. Okay. So I'm just going to redraw that. We've got 1, 1. We found this to be root 2. These were 45 degrees. What I want to do is I want to create a proportional triangle where the hypotenuse is not, it's not great, this is right triangle, where the hypotenuse is not root 2, but it's 1. So basically, I'm going to shrink the right triangle. Because remember, square root of 2 is 1 point something, right? So a triangle where the hypotenuse is 1 is going to be smaller. Okay? But this has to be proportional. So if I want to go from a root 2 hypotenuse to a 1, what would the new side lengths be of the leg, or what would the lengths of the legs be? Okay, think if I did this. You don't have to write this. Let's say I had, let's do a, that's a right triangle, 3, 4, 5. I want to make a proportionally bigger one. Yes, we don't add with proportions. It's what we multiply or divide if we're making smaller. Okay, so I'm basically doubling everything in this triangle. So I double this to get 6, I double this to get 8. So to get from here to here, I would times every side by 2. If I'm making it smaller, I would divide. So if I went from here to here, I divide everything by 2. Well, because I'm making it smaller, I got to divide. So root 2 divide what is 1? Root 2. Anything divide itself is 1. So it must be root 2. So therefore, what does it mean? Okay, stop it. This up here. This up here. So therefore, this side is going to be 1 divided by root 2, right? Because I have to, if I want to go from root 2 to 1, make it proportionally smaller, I got to divide everything by root 2. But we normally don't leave radicals like this, do we? Where there's a square root in the denominator. How do I get rid of that? Multiply top and bottom by root 2. So when I do that, up top I get the square root of 2, and on the bottom I get 2. Obviously, because these two are the same, these two are going to be the same. So this is also going to be root 2. There's a reason why we're making the hypotenuse 1 that you'll see shortly. Okay? So I want to focus on this one. I want to remember these values. When I make a 45, 45, 90 triangle with a hypotenuse of 1, the two legs must be root 2 over 2. Okay, that's something we want to sort of commit to memory, and you'll see it in a second. So that's with 45 degrees. What about other common angles like 30 and 60? Well, fortunately, we can actually make a right triangle that has both 30 and 60 in it. Because if I have a right triangle where one of the angles is 90 and one is 30, well, this 90 plus 30 is 120. This must be 60. Okay? So here, how do we make, so I want to do the same thing. I want to make a right triangle where the angles are 30 and 60 degrees, but the hypotenuse is 1. How can I do that? I'm going to start here. I'm going to make a equilateral triangle where all the sides are 2. Okay? Because I do equilateral, because if I take out half of the equilateral triangle, I get a right triangle where one is 30, one is 60, and one is 5. So let's focus on this one. This is 30 degrees. This is 60 degrees. This we call 2. This we don't know, but we do know this. Yeah, isn't it half of 2? So it's 1. Which means we can find this by Pythagoras. So now it's leg squared, that's one of the unknowns, plus 1 squared is 2 squared. Leg squared plus 1 is equal to 4. Leg squared is equal to 3. Therefore, the leg is equal to the square root of 3, which I believe is that. But remember what I said. I want a right triangle where this is still 30 up top here, this is still 60 down to the right here, but this becomes 1. I'm making it proportionally smaller. What must I divide this triangle by to get this one? 2, because 2 divided 2 is 1. So I must divide everything by 2. Well, what happens when you divide root 3 by 2? Well, we can't divide it cleanly, so leave it as a fraction. What happens when we divide 1 by 2? Can't divide it cleanly, so leave it as a fraction. There's the second triangle we want. If we've got a 30, 60, 90 triangle with a hypotenuse of 1, one of the sides is going to be 1/2, or one of the legs, and the other leg is going to be root 3 over 2. So you want to remember those 2 that we just did, because we're going to put them on a coordinate grid, which is what we're going to do now. And we're going to create something called the unit circle. Okay? What does the word unit mean? 1. So a unit circle has a radius of 1 and a center at the origin, 0, 0. So anytime I draw a radius, it's 1. I can draw in quadrant 2, quadrant 3, quadrant 4, wherever. I can create a right triangle out of it, like we did yesterday. Remember, the hypotenuse always came from the origin. One of the other sides was always on the x, and then the vertical side just connected to make up the right triangle. And remember this value here, well, here's an x coordinate, or here's a coordinate, x comma y. Whatever this point is, this will be this length, and this will be this length. So that's putting a right triangle in the unit circle, because remember it has to have a radius of 1, with a hypotenuse of 1. Remember, we just created 2 right triangles using angles 45, 30, and 60 that had hypotenuses of 1. So I wonder if that's hypotenuses or hypotenuse? Nah, okay, so let's take the 2 triangles we just did on the previous 2 pages and put them into the unit circle. So remember, here's how we draw our right triangle. If this angle is 45 degrees, this angle must also be 45 degrees. The hypotenuse is 1. Do you remember what the legs were? What were the legs when we did this triangle? Root 2 over 2 each of them. So therefore, this point on the unit circle must be root 2 over 2, comma, root 2 over 2. Has to be. Because we've already established that if we make a right triangle with a hypotenuse of 1 and angles of 45 degrees, these have to be root 2 over 2. No other values work. Now let's take the 30, 60, 90 triangle and fit them in. So notice this one is like the 30 degrees is coming out from here. So it's like dropping it on its side. So it's going to look like this. Remember, this hypotenuse is 1. This was 60 degrees here, although it really doesn't matter. We're just focusing. What were the side lengths of each in a 30, 60, 90? Which one's which? The one up is right. Just remember, 1/2 is smaller than root 3 over 2. 1 is smaller than root 3. Root 3 is 1 point something. This is just 1. So the smaller side in a 30, 60, or the smaller leg, will always be the 1/2. Therefore, this point must be the x value root 3 over 2, comma, the y value 1/2. Now, if we rearrange that 30, 60, 90 again and fit it in like this, so this is going to be 1. This is going to be 30 degrees. Well, the legs switch, right? The horizontal one is now 1/2, and the vertical one is now root 3 over 2, because we reoriented the triangle, the right triangle. So therefore, the point on the unit circle is 1/2 comma √3/2. So therefore, if the angle coming out from the origin is 45 or 30 or 60, you can tell me the point on the unit circle it hits. So here, I'm just going to go down to here for a second. I'm going to put these ones in here because we're going to talk about a couple of angles on there. If the triangle coming out from the origin was 30 degrees, this was the point on the unit circle. If the angle coming out from the origin or 0, 0 was 45 degrees, the point on the unit circle, the two values for x and y were the same. If it was 60 degrees, it's the reverse of 30. It's the same values. But reversed for 60. It's the same values as 30, but reversed for 60. Those are 3 angles. We're going to do lots more. But I'm just going to focus on sort of the first one. How about 0 degrees? Well, this is kind of weird because if you draw like a 0 degree angle, is basically each arm is on top of each other, right? What's the point there? The point. Point has 2 values.
1, 0.
1, 0. Because remember, the hypotenuse, that length is 1. So this must be 1, 0. At 90 degrees, your arm's going up here. What's the point on the unit circle? Remember, that's 1. 0, 1. So the point on the unit circle when the angle is 0 degrees coming out from the origin is 1, 0. At 90 degrees, it's 0, 1. Okay so far? Any questions? Okay. What we're going to do now is I'm not going to do the next 4 pages. We're going to go straight to the unit circle. The one that looks like this. Or the next 3 pages or whatever it is. The one that looks like this. We're going to go straight to here. Because we don't necessarily need all of this. This is going to be like your Bible in math. So let's put in what we've already done. We've already done 1, 2, 3, 4, 5 angles. Okay? And I'm going to use different colors. So I'm going to use a color for 0 degrees, for 90 degrees, and then we're actually going to keep going around the circle. And I'm going to use different colors for 45, and 60. All we want to do is, what are the points on the unit circle when the angle coming out is 0 degrees,
30, 45, 60, and 90. So what were those values again? For 0, it was 0. Sorry, what were those points? For 90, it was 0, 1. For 30, it was √3/2, comma 1/2. For 45, it was both of them √2/2. And for 60, it was negative 1/2 √3/2. But you notice by the unit circle, we've got a whole bunch of other angles. But guess what? All these other angles are related to these ones, which means they're going to have the same values in the points. It's just some may be positive and some may be negative because we're in different quadrants. Okay. So let's look at every 90 degrees. So we've got starting at 0, 90. What would this angle be? 180. What's the point on the unit circle at 180? Yeah, because we're going to the left, x is -1 instead of +1, y is still 0. Go down to here, which is 270. What's that point? 0, negative. Remember, we always start these angle measurements from here, right? So 0 degrees goes from here to here, 0. 90 goes from here to here, 90. 180 goes from here to here, like that, etc. Let's look at, and it's a family, we call it a family of 30 degrees. Who's part of this family? Every 30-degree angle that's coming out from the origin. So this one here is related to this one here, but what's the measure of this? How did you get 150?
From 0 to 30.
Yeah, like isn't this 30 here? Which means from here to here must be 150. What's the point then going to be 150? It's going to be the same values as these, except the first one's a minus. Next in the family is this one. What would the measure of this one be? Well, it would be 180 and then another 30. 210. And it would have the same numbers as the other two, except both are negative. So notice we're not having to know any new numbers, just positives and negatives. This one is the final member in the family. Well, all the way around is 360. We know that's 30, which means this must be 330. Same values, but watch your positives and negatives. Negative on the second one, right? And then we do the same thing for the 45 family and the 60 family. We've got the unit circle done. So 45 degrees, that's the one that sort of comes out into the middle of the quadrant, right? Comes out in the middle. So like this one would be corresponding, so would that one. Well, what's this one? We know it's 180 to here. We know it's 45 here to here. 135. And what are the values? The same as at 45, except the first one, x, is negative. Now we go to the next member in the family, which is down here, 225, because we take 180 halfway around, add 45. What are the values?
Negative root 2/2.
And,
Negative root 2.
right. Here's the last member in the family in quadrant 4. Well, we know all the way around is 360, and this is 45. 315. And the values will be the root 2/2's, except second one is negative. The 60-degree family. So remember the values at 60 degrees. What would this angle be in quadrant 2?
Negative 1/2.
No, the angle,
Oh,
120. Because it's 180 halfway around, less 60. And it would be negative 1/2, comma root 3/2. What would this one be in quadrant, angle B in quadrant 3? 240, because we do 180 plus 60. Same values, 1/2 and root 3/2, except both are negative. And this one, 300. Values are the same, except the second one, root 3/2, would be negative. There's only one I forgot. You may be able to see it. It's at 0, it's with 0 degrees. Not only is this 0 degrees, but it is also 360. So really, I can say at 0 degrees, the point on the unit circle is 1, 0. At 360 degrees, the point on the unit circle is also 1, 0. That is the unit circle. How do we remember these things? Everybody's got different ways. You can use your hands like that, if you can remember these. Okay, how do we remember the values? Well, these ones aren't bad because they have zeros, ones, or negative ones. But look at the pattern. Let's, like, look at the end. They're all over 2. Okay, so that's one thing you can commit to memory. But notice how it goes root 3, root 2, root 1, which is 1. And then it goes 1, root 1, root 2, root 3. Because really, if you can remember the ones here, these ones are pretty straightforward because they all have the same values. Sometimes students will get these two mixed up. The 45-degree ones, 45, 135, 225, and 315, are pretty easy. The two values are the same. Root 2/2. But sometimes students get these mixed up. So what you want to be careful with is, like, remember, there's a right triangle with 30 degrees coming out from here. The two sides are 1/2 and root 3/2. Which one is going to be root 3/2? The longer of the two legs. So that's root 3/2. The shorter one is 1/2. That's why we go long, short. But for 60 degrees, we go short, long. So this would be 1/2 here. This would be √3/2 here. That's sort of another way you can remember it. That's how I do it, short, long, long, short. Okay? Okay, so just looking at this, without looking at the next page. Here's the questions I can ask you right now. What point on the unit circle corresponds to an angle of 60 degrees? Yep, that's it. What angle, or sorry, what point on the unit circle corresponds to an angle of 225 degrees? Right. What point on the unit circle corresponds to an angle of 180 degrees? Yeah, right. Okay. Now you're going to have to commit this to memory right now. So we'll do it with this. Or I ask you the reverse. Okay. The point -√2/2, comma √2/2 corresponds to what angle on the unit circle? 135 degrees. The point 1/2, comma -√3/2 corresponds to what angle on the unit circle? 300 degrees. Flip the page. You'd be amazed at how quickly you can commit this to memory. Can you do this without flipping back? Try your best. First of all, here's some things to look at. Both are positive, right? So doesn't that mean first quadrant?
Yes.
So it's 30, 45, or 60. Well, it's not 45 because 45, they're the same numbers. So it's 30 or 60. Well, remember what I said. Long, short. So it's the lower angle. 30 degrees. This one, values are the same, so it's the family of 45. But it's not in quadrant 1. It's in quadrant 2. So how do we get that one in quadrant 2 and we know it's related to 45? 180 minus 45, which gives us 135. One, 0, those are the ones that are sort of either horizontal or vertical. 1, 0. 0. Somebody was saying it. 4, 360. So this one you got to be careful because it has 2 answers. Wow. What am I doing? What am I doing? Okay. 1/2 √3/2. I know I'm doing it in reverse. Is that 30 degrees? It's 60. Remember, 60 is short, long. 30 is long, short. Okay? So it's the family of 60 in quadrant 3. So 180, and then another 60, 240. This is short, this is long, short. So 30 degrees in quadrant 4. So it's almost going to look like this. I mean, you can sketch the triangle like that if you want. You can sketch the unit circle. It's 330 degrees. Like you could even sketch it like this to say, okay, 0, -1 is down here, right? So that means it must be this, which is 270 degrees. That's another way. A lot of times, just sort of a quick sketch of the coordinate grid. Excuse me.
Now let's go the other way.
So now you're given the angle, you got to tell me the point. √2/2, comma √2/2. 45-degree angle, which means quadrant 1, which means both values are positive. And again, here, like this one. Think of it like this if you need to. 180, well, it goes here. Well, what's the point on the unit circle there? -1, comma 0. $150 is like this, so it's long, short. And remember, √3/2 is the longer one, but it's in quadrant 2. So what's the coordinate?
-3/2.
-√3/2, comma. I can't hear you guys.
1/2.
Thank you. $240, again, maybe this helps you. So 180, 240, that's the short, long. Short, but they're both short and long, but they're both negative, so -1/2, -√3/2. 90 degrees just goes straight up here. 0, 1.
I mean, if you're getting some of these, you're already off to a good start. Because remember, we just did the unit circle, but it sounds like you guys are picking them up.
Which is good. What I'm saying is it's not as bad as you think. 315, that's the one that comes out in the middle here. That means they're identical. -√2/2, the second one has to be negative. And there we go.
Okay? That is the unit circle. So we want to keep practicing with that so you get comfortable with those numbers, because now we've got everything we need to do the trig. Okay? Now that we know the unit circle, now that we know these points and corresponding angles, we can introduce the trig.